Hello everyone, myself Amit Kumar, Assistant Professor in Computer Science and Engineering Department, Ajay Kumar Garg Engineering College, Ghaziabad. In digital mathematics, a very good topic, ring. Algebraic structure is there, a ring. So today's topic is ring. So one by one we can understand what is a ring, and in certain criteria we define a ring, type of ring, then properties, and with the help of some example we understand the terms ring. So what is ring? In discrete structure and theory of logic, a ring is a algebraic structure. This one is a algebraic structure defined over non-empty set R that contains two binary operation, addition and multiplication. The ring is satisfy the following condition. So please, at first we understand a algebraic structure with two binary operation, and these two binary operation are addition and multiplication only. So if these properties hold any algebraic structure is known as a ring. The first property with respect to addition operation. Therefore, we can say that the algebraic structure hold the abelian group with respect to addition, and second property with respect to multiplication. A algebraic structure hold the associative property with respect to multiplication, and third property hold the distributive law. Hold the distributive law, that means in addition operation and binary operation both. If these three property hold any algebraic structure, then this algebraic structure is known as ring. So operation addition unique element 0, multiplication is distributive over the addition, and under multiplication meaning of the product of non-zero element is also non-zero. One we can elaborate. Here two operations, addition and multiplication. We thoroughly understand this term. R is a non-empty set here, is said to be abelian group, is commutative. This one, that means R is a abelian group. This one is the first property. R dot, that means with respect to multiplication, this is multiplication operation here, is semi-group. And the third one is left distributive law, in A dot B plus C equal to A dot B plus A dot A. So this one is a left distributive law, is equivalent to right distributive law. If hold these three properties, the algebraic structure is known as a ring. So when we explain this abelian group, then we have a 5 properties, and this semi group we have a 2 properties, and this a single property, then 5 properties, then 2 properties and 1 property. That means if we want to prove that given structure is a ring or not, we prove the 8 properties. Total hold the 8 properties here. So a non-empty set R is a ring respect to a binary operation, addition and multiplication if the following 5 properties hold with respect to addition, and 2 properties with respect to multiplication, and this 1 property with respect to distributive. So total 8 properties is there. one by one we can elaborate it. See, this one is the closure property. The first one is closure property. Closure property says that if A and B is an element of R, therefore A plus B, we remember this binary operation addition here, is also in R. If hold this closure property, that means belong to A and B belongs to R, then operation A plus B also belongs to R. That means hold the closure property. The second one is ABC is belong to R, then A plus B, B plus C equal to A plus B plus C. So this one is associative law. This is known as associative. The third one is, that means this structure, this R have binary operation addition have a identity element here. Identity element, or that identity element in respect to addition is 0. So this identity element 0, that means A plus 0 equal to A, or we can say that 0 plus A equal to A. If we have a such type of property hold, this one is known as existence of identity. In respect to addition, the element is 0, identity element is 0, if this property hold. The fourth one is a inverse operation or a existence of inverse property. Existence of inverse, that means A belongs to R, that means minus A. Here we say that A plus Y equal to 0, that means this one is a identity element, and this Y is equivalent to minus A. So we can elaborate it A minus A, and this minus is here inverse operation and equal to 0. So we can prove that the existence of minus A here. If this type of a property holds, that we can say that the existence of a inverse. And this one is a commutative law. A plus B equal to B plus A, commutative law. If these four properties hold, the first one is addition, the first one is closure, the second one is associative, the third one is existence of identity, the fourth one is existence of inverse, and fifth one is commutative law. If these five property hold, we can say that this one is a commutative. This one is a commutative group. We write here commutative group. So if these property hold with respect to addition, and the second with respect to multiplication. With respect to multiplication, that means the first one is closure with respect to multiplication. A dot B hold in R if A and B belongs to R. And the second one is associative. This one is associative with respect to multiplication. A dot B dot C equal to A dot B dot C. So this one is associative. That means R with respect to multiplication is a semi-group. With respect to multiplication. And the third one is distributive law. This one is known as distributive law. Distributive law, that means left distribution is equivalent to right distribution. A dot B plus C equal to A dot B and A plus A dot C. And similarly, A dot B and A dot C dot A. So both are equal. Then if both are equal, then we can say that hold the distributive law. So commutative group with respect to addition, semi group with respect to multiplication, and hold the distributive law are abelian. Our algebraic structure is a ring, or R is a ring. So this one is a total 8 property that is used to prove the structure is ring or not. The next is type of ring. There are various type of ring. In some are null ring, commutative ring, ring with unity, and Boolean ring. So one by one we can elaborate. A ring is called a zero ring or null ring. So this one is also called a zero ring. If singleton is used with the binary operation, that means binary operation, or we can say addition operation or OR operation, thus this null ring can be described as the following. So we can say that 0 plus 0 is equal to 0 and 0 dot 0 is equal to 0. If we have this type of properties hold, we say that this one is a null ring. Commutative ring, a ring R will be called as a commutative ring if multiplication in a ring is also a commutative. Please see here, is known as commutative ring if multiplication in ring, this binary operation, multiplication binary operation ring is also a commutative, which means R is the right divisor of 0. So at first we understand this term, divisor, as well as left divisor of 0. So both right divisor and left divisor is 0. The commutative ring can be described as follows. If right divisor and left divisor is 0, then we have x dot y is equal to y dot x, where x and y belongs to non-empty set R. This ring will also called a non-commutative ring if multiplication is ring not a commutative. So non-commutative ring, that means if in binary operation multiplication is not commutative. Ring with unity. The third one is ring with unity is called a ring with unity if ring has an element E and that element is hold this property E dot x. E dot x is equal to x dot E. Okay. So if where the x is belongs to R. So if we have this type of a property, that means ring with unity, and this one is known as unity element here. Boolean ring. A ring is those every element is idempotent where A square equal to A. So please say that A square is equal to A, where A belongs to R. If we hold this type of a property, that means that this one is a Boolean ring. So these four type of a ring: null or a zero, commutative ring, ring with unity, and Boolean ring. In the first slide, when we talk about the type of ring, then the term is divisor. So we understand this zero divisor. If a ring contains two non-zero element x and y, non-zero element, if that means x and y is a element of any non-empty set R, then the ring will be known as divisor of 0 when the ring with 0 divisor can be described as this one. Y dot x is equal to 0. So please, y dot x is equal to 0 or x dot y is equal to 0, then we can say that this one is a non-zero element. Non-zero element. This one is a non-zero element and this one is a zero divisor can be described as. So x and y can be set to the proper divisor of 0, because the first case, please see this, x is the right divisor of 0, this one is the right divisor of 0, and similarly in a second case x is the left divisor of 0. So left divisor and right divisor here. 0 is described as additive element of R. Additive element of R because of this 0 here, described as 0 as an additive element. Ring without 0 element, 0 divisor. Product, please see here, this one is the product here. Product of two non-zero element x and y is 0 if a ring, the ring can be called a ring without 0 divisor. The ring without 0 element can be described as follows. Then properties of ring. All x, y, z belongs to R. Then the first one is minus x into minus y is equivalent to xy. These are the properties only. We can use directly if the given R is a ring. X dot 0 equal to 0 dot x equal to, this one is the x here, 0. Y minus z x equal to y x, this one is the dot here. So x dot y minus z dot x. And similarly x minus y equal to minus xy and minus x and y. Here the dot product. And the last x y minus z equal to x y minus x z. So this one is the multiplication here. Also this one is the multiplication. So these are 5 properties of a ring. So with the help of example, we can prove the given set is a ring or not. So Z is a set, or we can say the non-empty set with respect to addition and multiplication is a ring. The first example. So Z is belonging to all negative numbers and positive number included with 0. So we draw a table with respect to multiplication with the start to 0, 2 and so on. 0 and plus 1, plus 2, and so on. Minus 2, 0, plus 1, plus 2. So when we apply the operation of addition, we can say that all the element, we find the element here, all the element is belong to the Z. Therefore, closure property hold with respect to addition. The second one. In respect to addition, we can prove that associative law. This one is closure with respect to addition. Addition. Closure hold associative hold. Third one is 0 is the identity element because of minus 2 plus 0 equal to minus 2. So identity element is 0. Fourth is inverse. Minus 2 have a inverse is plus 2. That means when we apply addition operation, we find 0. Therefore, hold the inverse operation. Okay. And the fifth one is, please see. Fifth one is commutative law. Commutative law, that means minus 2 and plus minus 3 equivalent to minus 3 plus minus 2. So commutative law is hold here. Commutative. So 5 properties hold, that means with respect to addition. The 5 properties we have. And the sixth one is, that means in respect to, with respect to multiplication. Similarly we can prove with the closure with respect to multiplication. Because of this operation is multiplication here, we find all the result is belong to set Z. So closure law hold. And similarly, we prove that associative with respect to multiplication. That means -2, or we can say +2 into B in B A into B into C equal to A dot B dot C in respect to this non-empty set Z. Associative properties hold. And the last 8th is distributive law. We easily see that the left distributive is equivalent to right distributive. If hold these 8, then therefore we can say that Z, the given set Z, is a ring with respect to addition and multiplication binary operation. Similarly, we can prove a even for the even integer. Even integer, we suppose that the Z is R is in even integer. This one is a ring. Similarly, we draw a table and find out the given 8 properties. And a real number. If R is a real number, this also be a ring. We have proved with this the help of 8 operations. Thank you.